In this video, we're going to look at it using the chain rule to find a derivative. So we're given the function of two variables, z equals square root of 1 plus xy. However, x and y are functions of a single variable. X is tangent of t, y is inverse tangent of t. And we're being asked to find the derivative of z with respect to t using the chain rule. We could plug in what x is and what y is and do it like we would have done in Calc 1, but we're going to use our chain rule formula here to help us out. So according to the chain rule, our derivative with respect to t will be the partial with respect to x times the derivative of x with respect to t, plus the partial with respect to y times the derivative of y with respect to t. And now we'll do it in pieces. Our z is 1 plus xy raised to the 1/2. So we can bring the 1/2 down in front, decrease the power by 1. Derivative of the inside with respect to x is just the y. Derivative of x with respect to t is secant squared. So that first term is 1/2, 1 plus xy to the negative 1/2, times the y times the secant squared of t. In the second one, when we do the partial with respect to y, it looks very similar to our partial with respect to x, except that when we get to the inside function, we're now differentiating with respect to y, so we get an x that pops out. Derivative of y with respect to t is 1 over 1 plus t squared because we're differentiating the inverse tangent function. So that second piece becomes 1/2 times 1 plus xy raised to the negative 1/2 times an x times a 1 over 1 plus t squared. And then we can pull out a 1/2 times 1 plus xy to the negative 1/2 out in front. When we do that, we're left with y secant squared t plus x over 1 plus t squared.